Number 9. The cross-section on the number 6 EWG copper wire is 13.30 square meter, and the resistivity of copper at 20 degrees Celsius is 1.750 microohm centimeter. The length in meters of a number 6 wire to give a resistance of 0.06 ohm at 20 degrees Celsius. Let's start with the given so we can determine the unknown. Based on the given parameters of the statement of the problem, we have the given. So we have a cross-sectional area of 13.30 square millimeter and the resistivity of 1.750 microohm centimeter and the resistance of R 0.06 ohms. So we are tasked to determine the length, and it's stated that to determine the length in meters. Okay, so we are tasked to determine the length in meters. Okay, so we need to recall the formula for your resistance. So resistance is equal to the resistivity length all over the cross-sectional area. Okay, so if we do transpose in terms of length, therefore your length is equal to your resistance cross-sectional area all over your resistivity. Okay, substitute the value. What is the value for your resistance? We have 0.06 ohms. How about for your cross-sectional area? That is 13.30 mm squared. Okay, so your how about for your resistivity? Your resistivity is 1.750 micro ohm centimeter. Okay, so we need to do conversion. It's either we convert mm to centimeter or centimeter to mm. So in this figure, I think it would be easier if we convert the resistivity instead of the cross-sectional area, because cross-sectional area is squared, right? So instead of converting the cross-sectional area, it's better to convert our resistivity to become millimeter, so we can cancel out the cross-sectional area. Okay, in every centimeter, in every 0.1 centimeter, there is a 1 millimeter. Okay, so we do the cancellation. So our unit here is ohms. So micro ohms. Instead of we cancel out the ohms here, the square millimeter. We cancel out millimeter, the 1 of the millimeter, and the centimeter here. So instead of writing micro ohms in symbol, we can rewrite it to times 10 raised to negative 6. Okay, so solving for your length is equal to your length is equal to 45,600. The remaining unit is in millimeter. But wait, the requirement is in meter. So we need to convert millimeter to meter. In every millimeter, 1 millimeter, there is how many? In every 1,000 millimeter, there is a 1 meter. So we cancel out millimeter. So the remaining unit is in meter. So doing so, your final units is in meter. That is 45.6, 45.6 meter. So that is your answer.